In this lesson, we will develop a method for evaluating the limits of functions which cannot be done by direct substitution. Well, you know how to evaluate limits of functions. For example, if you want to find the limit x approaches, say 2, of x squared divided by 2x plus 1, what all you need to do is replace your x by 2 and find the value of that. But how about this? If I want to find limit x approaches 0, sine x divided by x. Now, how do you find the limiting value of this? If you set x equal to 0, sine of 0 is 0, so this will be 0 over 0. Now, that is a form that you cannot really calculate. Now, when it comes to situations like this, we need to have a different approach. So in this lesson, we will see how to evaluate limits like this, which cannot be done by direct substitution. Well, you know that limits of quantities like this can be actually done graphically. If you draw the graph of sine x divided by x, what kind of graph would you get? In the neighborhood of x equal to 0, the graph sort of looks like this, where this is 1. In other words, this limit is actually 1. Although, when you replace x by 0, this yields 0 over 0, the value of this limit is actually 1. Does that mean that 0 divided by 0 is 1? No, certainly not. 0 divided by 0 is a form that you cannot determine. Alright, so let's develop a method for doing these kind of limits. So, in this lesson, we investigate limits of the form limit x approaches c f of x over g of x. This is the form that we will investigate. Now, as I just showed you, limit x approaches 0 sine x over x is of the form 0 over 0. So when x equal to c, if f of x divided by g of x is 0 divided by 0 or infinity divided by infinity, then such a limit is said to be an intermediate form. It is of intermediate form. Now, intermediate form means the evaluation of this limit is not complete by doing this. You got to use another approach. Now, if limits are limits of this type means limit x approaches c f of x divided by g of x. If such limits yields 0 over 0 or infinity over infinity, when you do the direct substitution, then these limits are said to be of the intermediate form, and we have a rule that can be used to do that. LHopitals developed a rule for doing these kind of limits, and it is called LHopitals rule. So the rule says, if the limit of f of x divided by g of x as x approaches c produces an intermediate form 0 over 0 or infinity by infinity, then limit x approaches c f of x divided by g of x is the same as limit x approaches c f prime x over g prime x. Now, in other words, the limit of f of x divided by g of x as x approaches c will remain the same as limit x approaches c, the derivative of f of x divided by the derivative of g of x. Now, for example, can you do this in your mind? We have, in the beginning I told you, x approaches 0 sine x divided by x. Now let me write that down for you. Limit x approaches 0, all right, limit x approaches 0 sine x over x. Now, by direct substitution, this will give you 0 over 0. Now, according to LHopitals rule, this is the same as limit x approaches 0, the derivative of sine x, which is cos x, divided by the derivative of x, that will be 1. Okay, now look at the difference in here. So according to LHopitals rule, limit x approaches c, f of x over g of x is the same as limit x approaches c, f prime of x over g prime of x. So the example I gave you, limit x approaches 0 sine x over x. If you replace x by 0, you get 0 over 0. So it is of the intermediate form. If so, the rule says this will be the same as limit x approaches 0 of the derivative of sine x, which is cos x, divided by the derivative of x, which is 1. And now, replace your x by 0. What is cos of 0? Cos of 0 is 1. And 1 divided by 1 is 1. The value of that limit is 1. And you can prove that graphically. Alright. Okay, let's look at a couple more examples. Let's try this limit. Evaluate the limit. Limit x approaches 0, e to the power of 5x minus 1 all over 5x. Alright, let's try replacing x by 0. When x equals 0, this will be e to the power of 0 minus 1 divided by 0. What is e to the power of 0? E to the power of 0 is 1. Anything raised to the power of 0 is 1. So that will be e to the power of 0 minus 1 is 1 minus 1, which is 0. So this is of the form 0 over 0. When x equal to 0, we have e to the power of 5x minus 1 over 5x. That is 0 over 0. This is the intermediate form, which means we can apply LHopitals rule right. So since this is the intermediate form, we can apply LHopitals rule. What's the rule? We have limit x approaches c, f of x divided by g of x is the same as limit x approaches c of f prime x divided by g prime x. So this limit is the same as limit x approaches 0, the derivative of the numerator divided by the derivative of the denominator. That's right. Now tell me, what is the derivative of the numerator? The derivative of e to the power of 5x is 5 e to the power of 5x. Is that right? And the derivative of 5x is 5. So that will be limit x approaches 0, 5 e to the power of 5x divided by 5. Well, how about now? Can we replace our x by 0? And what do you get? Well, that will be limit x approaches 0, e to the power of 5x, because 5 and 5 will cancel. And what is limit x approaches 0, e to the power of 5x? Replace your x by 0. It gives you e to the power of 5 times 0, that is 1. So the value of this limit is actually 1. Try this on a calculator, see how the graph looked like. Well, put it on the calculator, y1 equal to, and draw the graph, and you can see as x approaches 0 from the left and x approaches 0 from the right, the value of that limit is 1. That's right. And if you watch carefully, actually there's a hole in the graph there, but the limit is actually 1. There's a hole there because the function is not defined for x equal to 0. Is this function defined for x equal to 0? No. So there will be a hole in the function graph at x equal to 0. But the limit from the left is equal to the limit from the right, equal to 1. All right, let's do another one. Evaluate the limit x approaches negative 1 of 2x squared minus x minus 3 divided by x plus 1. All right, try doing this. Replace your x by negative 1. And the numerator become negative 1 squared is positive 1. 2 times 1 is 2. And minus negative 1 will be positive 1. 2 plus 1 is 3. 3 minus 3 is 0. So the numerator becomes 0. And x replaced as negative 1, the denominator also is 0. So the numerator and the denominator both are 0. Therefore, this is of the intermediate form. Remember, you can use LHopitals rule only if the limit yields the intermediate form. Since this is the intermediate form, we can now use the LHopitals rule. What is that rule? Limit x approaches c, f of x divided by g of x is the same as limit x approaches c, f prime of x divided by g prime of x. So that will be limit x approaches negative 1, derivative of the numerator divided by derivative of the denominator. And what is the derivative of the numerator? That will be 4x minus 1. And the derivative of the denominator is 1. So that is limit x approaches negative 1, 4x minus 1 divided by 1. Can you replace now x by negative 1? Well, that's right. So that will be 4 times negative 1 minus 1 divided by 1. And that is negative 5. Now, can you draw a graph of this 2x squared minus x minus 3 over x plus 1 and see if the limit is actually negative 5? Well, this is the graph of this. Try that on your own. You can see this is actually a removable discontinuity here. You can factor the numerator and cancel that x plus 1. But you can see when you graph this, the graph will have a hole at x equal to negative 1. Watch this. This is x equal to negative 1. I don't know whether you can actually see. That's the x equal to negative 1 and you have a hole there. But limit x approaches negative 1 from the left as well as from the right. That limiting value is negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. That's the limiting value there. Alright. And I've shown you that hole in there. Let's try another one. Evaluate the limits. Limit x approaches infinity, 2x plus 1 over 4x squared plus x. Well, it's very clear that when you replace x by infinity, this will be of the form infinity plus infinity. Because when x equal to infinity, 2x plus 1 is infinity. Alright, so this is of the form infinity divided by infinity. This is of the intermediate form. Therefore, we can use LHopitals rule there. And what's that rule? Limit, I'm going to repeat it every time. Limit x approaches c, f of x divided by g of x is the same as limit x approaches c, f prime x divided by g prime x. So this will be limit x approaches infinity, derivative of the numerator divided by derivative of the denominator. And that will be derivative of the numerator is 2. Derivative of the denominator is 8x plus 1. There you go. Alright, now tell me if you understand the concept. What happens if you replace your x by infinity? It will be 2 divided by 8 times infinity plus 1. Well, if you multiply infinity by any number, it will still be infinity. If you add any number to infinity, it will still be infinity. That means 8 infinity plus 1 is infinity. What is 2 divided by infinity? What do you get if you divide a number by infinity? These are important concepts that you cannot do without. When the denominator becomes infinity, the value of that number is 0. Any number divided by infinity is 0. So the value of this limit is 2 over infinity. That is 0. Okay, let me ask you, what is the value of, how about this? What is the value of limit x approaches infinity e to the power of negative x? What is the value of that? X approaches infinity e to the power of negative x. Well, it is x approaches infinity 1 over e to the power of x, and when x goes to infinity, it will be 1 over infinity, and that will be 0. And if you know the graph of this e to the power of negative x is an exponential decay graph, and as x goes to infinity, you see the graph will asymptotically approach the x-axis. That is the meaning. Limit x approaches infinity, e to the power of negative x is 0. Okay, let's do another one. Evaluate the limit square root of 4 minus x squared. Limit x approaches 2 from the left. Square root of 4 minus x squared over x minus 2. But why do we have this limit x approaches 2 from the left? Because for this x cannot approach 2 from the right. Why not? Because if x approaches 2 from the right, this value will be greater than 2 squared. That will be inside the square root, you get a negative sign. So this quantity is defined only if x approaches 2 from the left. In other words, x squared has to be less than 4. Okay, try this. Well, if you replace your x by 2, you get 4 minus 4, 0, 2 minus 2, 0. That will be 0 over 0. There you go. That is the intermediate form. That means this limit can be evaluated only by using LHopitals rule. So that will be limit x approaches 2 from the left, square root 4 minus x squared over x minus 2 is the same as limit x approaches 2 from the left, the derivative of the numerator divided by the derivative of the denominator. Alright, let me see how many of you remember what is the derivative of square root of 4 minus x squared. It is easy to remember like this. The derivative of a square root quantity, this is the quantity, is 1 over 2 square root of that quantity multiplied by the derivative of that quantity. So the derivative of this will be, now look at the way I'm going to write with my marker, my pointer here. The derivative of this quantity will be 1 over 2 square root of that quantity, 4 minus x squared, times derivative of this quantity is negative 2x. So the derivative of this will be actually negative 2x divided by 2 times square root 4 minus x squared, and the 2 and 2 will cancel. You see, this will be 1 over 2 square root 4 minus x squared times the derivative of 4 minus x squared is negative 2x. Alright, that's the derivative of this. And what is the derivative of x minus 2? That is 1. Alright, can you now replace x by negative 2 and see what happens? Simplify this, you get limit x approaches 2 from the left, negative x over square root 4 minus x squared. And if you replace x by 2 here, the denominator becomes 0, the numerator it will be negative 2. Is that right? So replace x by negative 2, that will be, well, this is not quite right. Yes, it is right. X approaches 2 from the left. Replace both your x by 2. That will be negative 2 divided by square root 4 minus 2 squared. That will be negative 2 over 0. What is a number divided by 0? A number divided by 0 is infinite. So this will be negative infinity. The limit x approaches 2 from the left of this quantity is negative infinity. Now, can you try that on your calculator? Now look at this. This is the graph of this function as x approaches 2 from the left. This is x equal to 1, x equal to 2. As x approaches 2 from the left, what happens to the function? It goes to negative infinity. Now, you see why x cannot approach 2 from the right. Because the function is not defined for x greater than 2. Okay. Another one. Evaluate the limit. Limit x approaches 1, ln x over x squared minus 1. Can you test if LHopitals rule can be applied here? What's the condition for LHopitals rule to be applied? When a direct substitution of the limit should give you an intermediate form, 0 over 0 or infinity over infinity. Alright, replace x by 1 here and see what form is this. What is ln of 1? ln of 1 is 0. And when replace x by 1, this is 1 minus 1, 0. That is 0 over 0. So that is intermediate form. And therefore, we can use LHopitals rule. Limit x approaches 1, ln x over x squared minus 1 is the same as limit x approaches 1, the derivative of the numerator divided by the derivative of the denominator. That's right. And what is the derivative of ln x? Derivative of ln x is 1 over x. And the derivative of x squared minus 1 is 2x. So that will be limit x approaches 1 of 1 over x divided by 2x. What is that equal to? 1 over x divided by 2x is 1 over 2x squared. And what is the value of this when x equal to 1? That will be 1 over 2 is the value of that limit. Alright, try that graphically and see if you can get it. Alright, what's this graph? This is the graph of ln x divided by x squared minus 1. Now watch what happens when x approaches 1 from the left and x approaches 1 from the right. You notice here that this function is not defined for x equal to 1. You can see there's a hole there. That indicates that the function is undefined at x equal to 1. But as x approaches 1 from the left and x approaches 1 from the right, the function value approaches 1/2. Now this is 1/2 because I have used the scale so that that's 1, this is 1/2. Okay. Another one. Evaluate the limit. Limit x approaches 0, sine ax divided by sine bx. Sine ax divided by sine bx. Can you replace x by 0 and tell me what form this is? When x equal to 0, you get sine of 0. What is sine of 0? Sine of 0 is 0. So you get 0 over 0. And That is intermediate form. Therefore, we can use L'Hopital's rule. Limit x approaches 0, sine ax over sine bx is the same as limit x approaches 0, derivative of sine ax with respect to x divided by derivative of sine bx with respect to x. There you go. What is d by dx of sine ax? The derivative of sine ax is cos ax times the derivative of ax, which is a. So the derivative of sine ax is a cos ax. And the derivative of sine bx is b cos bx. So this will be limit x approaches 0, a cos ax divided by b cos bx. And now if you replace x by 0, what happens? Do that. When x equal to 0, ax is 0, what is cosine of 0? Cos 0 is 1. So on the numerator and the denominator, cos 0 becomes 1, and therefore the value of that limit is a over b. That's right. So limit x approaches 0, sine ax over sine bx is a over b. Limit x approaches 0, sine 2x divided by sine 3x will be 2 over 3, and so on. All right. How about another one? Evaluate the limit. Limit x approaches 1, arc tan x minus pi by 4 over x minus 1. Okay, if you replace x by 1, what does that give you? What is arc tan 1? I'm sure you know that. Tan of pi by 4 is 1. Therefore, arctan of 1 is pi by 4. Arctan 1 is pi by 4. So the numerator becomes pi by 4 minus pi by 4. And the denominator is 1 minus 1. That will give you 0 over 0. So you got arctan 1 minus pi by 4 is the numerator. 1 minus 1 is the denominator. And arctan 1 is pi by 4. So we get the form 0 over 0, which is the intermediate form. Therefore, we can apply the L'Hopital's rule. And what is that rule? Limit x approaches 1, arctan x minus pi by 4 over x minus 1 is the same as limit x approaches 1. The derivative of this, the derivative of the numerator is simply the derivative of arctan x. Is that right? Because the derivative of pi by 4 is 0. All right. Do you remember what is the derivative of arctan x? Yeah, that's very important to know. So that will be the derivative of arctan x minus pi by 4 divided by derivative of x minus 1. And that is limit x approaches 1, the derivative of arctan x is 1 over 1 plus x squared. And the derivative of x minus 1 is 1. Well, this will be, what is 1 over x squared divided by 1? That is 1 over x squared. Can you replace now x by 1? So that will be limit x approaches 1 of 1 over 1 plus x squared. And when x becomes 1, the value of this is 1/2. Therefore, limit x approaches 1, arctan x minus pi by 4 divided by x minus 1 is 1/2. Can you do this graphically? Well, here we have the graph. As x approaches from the left and x approaches from the right, the value of the function approaches 1/2. And if you look very carefully, you can see a hole in the graph there. That means this function is not defined at x equal to 1. the function is not defined at x equal to 1, but the limit of the function as x approaches 1 from the left and the x approaches 1 from the right will be 1/2. All right. Another one. Evaluate the limit. Limit x approaches 0 from the right of e to the power of x plus x, all raised to the power of 1 over x. Well, is that an intermediate form? Well, we have an exponent here, and in order to do the derivative, we actually have to use the logarithmic approach here. So what we're going to do is, because we have a power 1 over x, we're going to call this quantity, this limit, let the limit be called y. So we say let y equal to limit x approaches 0 from the right, e to the power of x plus x, all raised to the power of 1 over x. Now, whenever we have quantities that are raised to the power that contains the variable, this is the approach that we need to take. So let y equal to this limit. Our aim is to ultimately find y, because what we want is the value of this limit. We call this value of the limit to be equal to y. Well, what happens if you take ln of both sides? Let's do that. Take ln of both sides. Take the ln of the left side will be ln y, and the right side is ln of limit x approaches 0. Is that right? So taking ln of both sides, we get ln y equal to limit x approaches 0. See, we can put that process outside ln. We can say ln of limit x approaches 0 of this quantity, which is the same as limit x approaches 0 from the right of ln e to the power of x plus x raised to the power of 1 over x. All right. Now, when you have ln of a power, remember the power gets multiplied. Is that right? Ln of x to the power of a is a ln x. So ln of e to the power of x plus x raised to the power of 1 over x is 1 over x times ln e to the power of x plus x. That's right. So that will be limit x approaches 0 from the right, 1 over x ln e to the power of x plus x. Well, this is the same as ln e to the power of x plus x divided by x. There you go. Now, this is of the form f of x divided by g of x. You can see our original expression was not of the form f of x over g of x. Now, if you want to apply LHopitals rule, the function, the expression has to be of the form f of x divided by g of x, and a direct application of the limit must give you 0 over 0 or infinity over infinity. Now, our original expression actually was not of f of x over g of x form, but by calling it equal to y and taking ln of both sides and simplifying the right hand side, you can see what the right hand side has now become. The right hand side is limit x approaches 0 from the right, ln e to the power of x plus x over x. This is now of the form f of x over g of x. Alright, if you replace x by 0, what do you get? Can you think of it? When x becomes 0, e to the power of 0 is 1, and this x will become 0, so the value inside the parenthesis is 1, but ln 1 is 0. So the numerator becomes 0, and the denominator, when x is replaced by 0, is also 0. So that is of the form 0 over 0. That means we can apply L'Hopital's rule now for this limit. And so, let's do that. Now, this is what we have. Our left-hand side is lny. We are not going to touch it. We're going to leave it there. The right-hand side is this. And we just said when x is replaced by 0, this will be of the form 0 over 0. And therefore, we can use L'Hopital's rule. This will be the same as limit x approaches 0, the derivative with respect to x of ln e to the power of x plus x divided by derivative of x. Okay, and now tell me what is the derivative of ln e to the power of x plus x. Now try and write it down in a piece of paper, the derivative of an ln quantity. Remember, the derivative of an ln quantity is 1 over that quantity times the derivative of that quantity. Alright? Here the quantity is e to the power of x plus x. So the derivative of ln of this quantity will be 1 over that quantity, 1 over e to the power of x plus x, times derivative of this quantity. What is derivative of e to the x plus x? It will be e to the power of x plus 1. So the derivative of ln e to the power of x plus x will be, what will that be? It will be e to the power of x plus 1 divided by e to the power of x plus x. And the derivative of x will be 1. So, I don't know whether you can actually see this on the screen, but this will be limit x approaches 0. The derivative of this quantity, I'm going to repeat again, the derivative of this quantity will be 1 over the quantity. Let me write that down for you. Like this. The derivative of d by dx of ln e to the power of x plus x will be the derivative of a quantity. Now here, this is our quantity, ln of a quantity. Derivative of ln of a quantity is 1 over that quantity. Look at this. 1 over that quantity, e to the power of x plus x, multiplied by what? Multiplied by the derivative of that quantity. Now the derivative of e to the x plus 1, e to the x plus x is e to the x plus 1. So that gives you e to the x plus 1 on the numerator and e to the x plus x on the denominator. And that's what the derivative of the numerator is. Derivative of this quantity, that is what I have here. E to the power of x plus 1 over e to the power of x plus x. That is the derivative of this. And the denominator, of course, is 1. Okay. And because the denominator is 1, we don't need to worry about it. So that's the same as limit x approaches 0 from the right, e to the power of x plus 1 over e to the power of x plus 1. Can you now apply x equal to 0 there? That will be e to the power of 0 plus 1 over e to the power of 0 plus 0. That will be e to the power of 0 is 1, 1 plus 1 is 2, divided by 1, and that's equal to 2. Yes, that limit is 2. But have we found the actual answer? Well, we are looking for this limit and not this limit. Remember, this limit is ln y. We started this by taking ln of both sides. So, this quantity we just evaluated, which gave you 2, is actually equal to ln y. So we haven't finished. So we have ln y equal to 2. Therefore, what is y? If ln of y equal to 2, then y equal to e to the power of 2. That's right. So, we have y equal to limit x approaches 0 from the right of this quantity, and that gives you y equal to e to the power of 2. That means the value of this limit is e to the power of 2. And here I have the graph of that quantity. As x approaches 0 from the right, as x approaches 0 from the right, the value of the expression becomes e to the power of 2. This is actually e to the power of 2. All right. Let's try another one. Evaluate the limit. Limit x approaches 2 from the right of 1 over x squared minus 4 minus square root of x squared minus 4. X approaches 2 from the right. Now, why is x approaches 2 from the left? What happens if you have x approaches 2 from the left? If x is approaching 2 from the left, the x values will be less than 2. When x values are less than 2, x squared values will be less than 4, and that will give you, will that make any difference there? Well, that will make the denominator, that's not much of a problem, but we are looking for limit of this when x approaches 2 from the right. Now, if you replace x by 2, what will happen? Do we have any expression there? Direct substitution of x equal to 0 gives, replace x by, well, we are not replacing x by 0, but x by 2. Is that right? So, let's do some simplification there and see what happens. 1 over x squared minus 4 minus square root x minus 1 over x squared minus 4. We can write it as a single quantity by taking the common denominator. X squared minus 4 is the common denominator. So that becomes 1 minus square root x minus 1 divided by x squared minus 4. And if you replace x by 2, not x equal to 0, we got to replace x by 2. What happens? It will be 1 minus square root 2 minus 1 over 2 squared minus 4. Now, the numerator is 1 minus 1, that is 0. Denominator is 4 minus 4, that is 0. So this is of the intermediate form. Well, therefore, this limit x approaches 2 from the right of this quantity is the same as limit x approaches 2 from the right of this simplified form. In other words, we combined it into f of x divided by g of x. Remember, LHopitals rule can be only applied if the limit is of the form f of x divided by g of x. So this is our f of x, and this is our g of x. And therefore, since this is of the intermediate form, this limit will be limit x approaches 2 from the right, the derivative of the numerator divided by derivative of the denominator. Okay. Tell me, what is the derivative of 1 minus square root of x minus 1? The derivative of 1 is 0 minus, what is the derivative of square root x minus 1? Now again, remember the dictum I gave you. The derivative of a square root quantity will be 1 over 2 square root of that quantity times derivative of the quantity. The quantity here is x minus 1. So derivative of square root x minus 1 is 1 over 2 square root x minus 1 times derivative of x minus 1 is 1. Therefore, the derivative of the numerator will be negative 1 over 2 square root x minus 1. The derivative of the denominator will be 2x. So there you go. The derivative of the numerator will be negative 1 over 2 square root x minus 1 over the derivative of x squared minus 4 is 2x. Now simplify this, it will become negative, the 2x will stay on the denominator. It will become limit x approaches 2 from the right of negative 1 over, look at that, this 2x will combine with this 2, give you 4x square root x minus 1. And can we now replace x by 2? Well, we can do that. So that will be 1 over 4 times 2 square root 2 minus 1. We don't need that limit quantity now because we have now applied the limit. So the value of this equal to this, and that will be negative 1/8. The value of that limit is negative 1/8. And look at that graph. You can see x approaches 2 from the right. As x approaches 2 from the right, I have drawn this graph. So this is x equal to 1, x equal to 3, x equal to 2, x equal to 1, x equal to 0. That's the origin. So as x approaches 2 from the right, the value of this expression approaches 1 over 8, and you can see the big hole there that shows the function is not defined at x equal to 2, but the limit is defined and it is equal to negative 1/8. All right. Let's try an application problem in here. The formula for the amount A in a savings account compounded n times per year for t years at an interest rate of R and an initial deposit of P is, I'm sure you have seen this equation in a pre-calculus or college algebra class, is A equal to P times 1 plus R over N, the quantity raised to the power of N times T, where P is the amount of money deposited for a period of T years and the interest is calculated N times a year. Now show that for continuous compounding. What's the meaning continuous compounding? Means interest is calculated continuously. If n is the number of times the interest is calculated, now for example, if the interest is calculated 6 monthly, then n equal to 2. Is that right? But if the interest is compounded continuously, what's the value of n? The value of n will be infinite. There will be infinite calculations every year. So what we are required to find is the limit of this quantity when n goes to infinity. Show that that limit equal to p e to the power of rt. So continuous compounding means n, the number of times the interest is calculated, is infinite. And the formula for continuous compounding is the limiting value of this a. You see, this gives you the amount A after t years if interest is calculated n times a year, where n is finite, no problem there. If interest is calculated 12 times a year at the end of every month, we can do that calculation there. Now the question is, what will be the value of A when n is infinite? That means n goes to infinity. So then A will be limit n goes to infinity p times 1 plus r over n, all raised to the power of nt. Now we need to find the value of this. Okay, now here we have a power that contains the variable. T is our variable, is that right? Interest is calculated with time. Now that means we need to make an approach here. What kind of approach? When the expression has a power that contains the variable, the best way to deal with is what? Take ln of both sides. We have A equal to this quantity. Therefore, we take ln of both sides and then proceed from there. Alright, help me take the ln. It will give me ln A equal to limit n goes to infinity of ln of this quantity. There you go. So, ln A equal to limit n goes to infinity ln of this quantity. Alright? Can you write this in a simplified form? Ln of P times a quantity will be ln P plus ln of that quantity. Ln A times B is ln A plus ln B. So, first of all, we simplify this as ln of P times this is ln P plus ln of 1 plus r over n to the power of nt. Okay, since p is a constant, we can take it out of the limit. You see, limit n goes to infinity does not apply to ln p because p does not contain n. So we can actually remove it from the limit and take only the limit of this quantity. So how does that become then? It'll become, you've got to read it like this. ln A equal to ln P plus, we just take it out of the limit, ln P plus limit n goes to infinity of this quantity, ln 1 plus r over n to the power of nt. Okay, let's go to the next page. And how do we deal with that limit? Well, ln, you know that ln of a to the power of x is x ln a. So it becomes now nt gets multiplied. It'll be nt ln 1 plus r over n. Now, look at the manipulation I'm now doing here. In order that we may evaluate this limit, n goes to infinity, since the direct substitution doesn't give you any meaningful limit, we got to see if LHopitals rule can be applied. Now, in order to use LHopitals rule, the expression has to be of the form f of x divided by g of x. And now, if you notice, our variable here is n. We want to find the limit when n goes to infinity. So that's the variable there. So, instead of multiplying n on the denominator, I just divide it by 1 over n. Now, does it make a difference? We have n times t here. So that n from the numerator, I took it and put in the denominator as 1 over n. Remember, a 1 over n in the denominator is the same as an n on the numerator. This is just a manipulation for what? To bring it in the form f of x over g of x. So, nt ln r 1 plus r over n now becomes t times ln 1 plus r over n divided by 1 over n. In actual fact, there is no difference between these two. This 1 over n, the n goes up. But it serves us well now, because now this is of the form f of x over g of x. Alright, if you now replace n by infinity, what will happen? R over infinity will be infinity. Infinity plus 1 is infinity. ln infinity is infinity. Is that right? And the denominator is? Well, okay. Now, this becomes 0 over 0, which is infinity. And therefore, the limit of f of x divided by g of x, because this is of the intermediate form, can be now written as derivative of the numerator times derivative of the denominator. Now, I want to warn you here. Remember, t is not a variable in this case. Why? Because we are looking for limit n goes to infinity. N is our variable. So t is not the variable. The number of years is going to remain. We're going to get the interest calculated for a given number of years when the interest is calculated continuously. So the variable here is n, not t. So we need to find d by dn, the derivative with respect to n of this quantity, not with respect to t. Therefore, t is a constant there. Alright, what is d by dn of this quantity, since t is a constant? And remember again, the derivative of an ln quantity. Now, I'm going to repeat that again. The derivative of an ln quantity is 1 over that quantity, 1 over this quantity, multiplied by derivative of this quantity. That means the derivative of this will contain 1 plus r over n on the denominator and the derivative of this quantity on the numerator. Alright, tell me, what is the derivative of 1 plus r over n with respect to n? Derivative of 1 is 0. The derivative of r over n with respect to n. Alright, anybody? That's actually an extra credit question. The derivative of a over x with respect to x is negative a over x squared. The derivative of r over n with respect to n is negative r over n squared. Therefore, the derivative of this quantity will be negative r over n squared divided by 1 plus r over n. And of course, this will be also on the numerator. Alright, that's the derivative of the numerator. What's the derivative of the denominator? D by dn of 1 over n is negative 1 over n squared. There you go. Alright, look at this again. The derivative of this is t times 1 over the quantity, 1 over r over n, times the derivative of 1 plus r over n is negative r over n squared. One more time. T is a constant, that will remain there. Times 1 over this quantity is this. Times the derivative of that quantity is this. Divided by negative 1 over n squared. And if you notice there, this r can go and join here as r times t, and negative 1 over n squared and negative 1 over n squared can cancel. Alright, let's try it again. As I said, that r can go and join there. There you go. So you get, that will be rt over 1 plus r over n, multiplied by negative 1 over n squared over that negative 1 over n squared. That will cancel, leaving us with this quantity. So the right hand side of the expression now has ln p, that will be ln p plus limit n goes to infinity of this quantity, rt over 1 plus r over n. Okay, what is the value of this limit? Now if you apply n equal to infinity, if you replace n by infinity, what is r over infinity? When infinity comes on the denominator, the value becomes 0. So when you replace n by infinity, this will become 0. Therefore, the limiting value of this will be rt. There you go. So that will be, on the right side, we get ln p plus the limiting value of this when n is replaced by infinity, that will become 0. So we get ln a equal to ln P plus RT. That's how you should read it. ln A equal to ln P plus RT. Or ln A minus ln P equal to RT. Alright, what's ln A minus ln P? Ln of A divided by P. There you go. Ln of A divided by P is RT. And now change the ln form to exponential form. If ln of A over P equal to RT, what is A over P? If ln x equal to y, then x equal to e to the power of y. If ln A over P equal to RT, then quantity A over P is e to the power of RT. There you go. So we get A over P equal to e to the power of RT, and that gives you A equal to P e to the power of RT. We have solved for A, and we got the expression for when interest is calculated continuously, the amount of money invested for a period of T years at an interest rate of R will be A equal to P e to the power of RT. Now this is a very interesting and an important type of problem. I want you to go back and maybe try this on your own, some of these steps. Alright? Okay, now try and do this on your own. Use LHopitals rule to find limit x approaches infinity, x sine 1 over x. I'll give you a clue. And the clue is, in order to use LHopitals rule, you must have the expression of the form f of x over g of x. And a direct substitution of the limit should give you the intermediate form 0 over 0 or infinity over infinity. Alright, how do we write this in the form f of x over g of x? We did this in the last problem. Remember, we said nt times a quantity, we wrote it as t times the quantity divided by 1 over n. The same way, x sine 1 over x can be written as sine 1 over x divided by 1 over x. That's right. There you go. Now you can proceed and see how you can get the results there. What is the limit of x approaches infinity? X sine 1 over x. All right?